Hello guys, in this video I'm going to show you how to solve minimum subset sum difference. Okay. So given a set of positive numbers, partition the set into two subsets with minimum difference between their subset sums. Right. So it shares a lot of things in common with the subset sum problem, right? But here also with the equal subset sum partitions, right? Here we need to partition into two subsets with minimum difference in their sum, right? So in this is a dynamic programming program. So yeah, of course there are two approaches that we can take. In this video I'm going to show you how to solve it in top-down approach, right? So for top-down approach, we start with the original problem, right? We try to model the original problem and try to find smaller problems that we can calculate, right? So first, let's try to model a problem here, right? And maybe try to brute force it, right? So our function will be find the minimum subset sum difference, right? So problem here is given this input, right? This how to partitions the numbers from the input, right, into two subsets, right? So the most intuitive way, the most easy way should be to try to gonna iterate for every number, right? And for each number we have two choices, which is either to put to the set A or put to the set B, right? So that should be our subproblem, right? So for example here we have 1, 2, 3, 9. For example, with this input, right? Going to iterate. Consider every number. First is number 1. So for this one, we have two choices, right? Either put it in the let's say we have A and B, right? Here we have two choices. Number 1, either put it in A or put it in B, right? So again, so we're done with this level. So we will consider the next number, right? So for number 2, considering number 2, for each for each choice, for each let's say for this way, we can, for this one, we can have further 2 more choices here, which is put A to put 2 to the to A, or put 2 to B, right? So here 1, 2, or 2 come here, right? So same here for this one, we also have 2 choices. 2 come here, or 2 come to the B set, right? So next, right, next level, when consider the next number, which is 3. Again, for each options, for each possibility from the previous level, we have 2 more we have 2 more ways that we can go. So considering 3, we can put 3 to A or B. If 3 come here, or 3 come here, right? Next, right, for this possibility, we have 2 choices also. 3 come here, or 3 come here. So as you can see, as we add more number to either A or B, we probably want to calculate the sum, right? We keep track of the sum, so that when we out of number, we can differentiate the sum between 2 subsets, right? So let's continue with our approach. So next here, for this one, we have 2 choices also. 3 come here, or 3 come to A, or 3 come to B. Next, this one, we have 2 choices also. 3 come here, or 3 come here. Okay. Next, and also the last number, 9. Okay. So it, yes, here we have 2 choices also. 9 come here, or 9 come here. Okay, for this one, I copy down here, and now I will add 9 to A, or 9 to B. Next one, say we're here. Next one is here. Okay, Same here, 9 can come to A or 9 can come to B. Next, we've got 1, 3, got here, 6 here. Okay, next one is this one. Okay, 9 can come here, or 9 can come here. Right, this takes a little bit of time here, but let's go into further details of how the algorithm works so that you can understand it thoroughly. I'm gonna move to the next slide for the last 4 choices. So let's copy it out here and okay. Now I'll copy this over here. Copy this over here. Right. So for each choice from the previous level, we will have 2 choices, right? Whoops. Okay. So same here. These 2, 9 can come A or 9 can come to B. 9 can come to A. Or 9 can come to B. 9 can come to A. Or 9 can come to B. Same here. Okay, we're done. Here is all the possibilities that we can have as we try to divide, to partitions our input into 2 subsets, right? So next is to find the sum of each subset and find the difference between 2 sums, right? So for the first one here, let's say sum of all the number in subset A is 15, right? 15 versus 0, so it's 15, right? Next, find 6 versus 9 is 3, right? Here we need to find the difference. We don't care about the we need the absolute value, right? We don't care whether it's 6 minus 9 or 9 minus 6. Next one. Okay, 10, 12 versus 3, so it would be 9, right? Okay, the difference is 9. Next, a 12 versus 3, 3 versus 12, right? As you can see, it's the same here. Oops. We have the same here, right? 12, 3, Okay, let's go to the next one. 10, 13 versus 2, so difference is 11. Next one, 4 versus 11, so the difference is 7. 10 versus 5, difference is 5. 1 versus 14, difference is 13. Okay, next, 14 versus 1, 13. As you can see here, we have the same thing but just different order here. A is 1, A contains 1, here B contains 1, here B contains 2, 3, 9, here A contains 2, 3, 9. So the order is different, right? So it's probably something that we want to optimize, right? We can optimize because it's just the same set, so we don't want to recalculate it. Okay, next. We have 5 here and 10, so the difference is 5. 11 and 4, difference is 7. 2 and what is that? 13, difference is 11. 12 and 3, difference is 9. 3 and 12, difference is 9. 9 and 6, difference is 3. 0 and 10, 15, difference is 15. So as you can see here, the minimum difference that we can have is 3, which can be taken from this way of partitioning, or this one. Right? We can put either 9 to B or to A, the same here, right? So for the top-down traversal, for the top-down approach, we start at the original questions, right? Try to find subproblems, right? Until we got to the end, and want to keep track. We need to we have to decide what kind of informations we want to keep track. It's obviously that here we are using recursions here, right? So what kind of state that we want to keep track amongst the recursive call. So do we really need the numbers in each subset? The answer is no, because here what we care about is the current sum, right? So that we can calculate the difference, right? So how about we keep track of the sum, sum 1 and sum 2, Sum 1 would be the sum of all the number in the first subset, and sum 2 will be the sum of all the number in the second subset, right? So initially it will be 0, right? So as we go down, as we go down the recursion tree, gonna add number to the sum, right? Initially is 0, right? So initially we have initially we will have 2 empty, because initially we have 2 empty subsets, right? So initially it will be 0. What else do we need here? Oh, okay, we have numbers with sum 1 or sum 2 and sum 2. Okay. The other things that we want to keep track of here is the current index. Is initially 0. Current index is a number that we are considering at current recursive call, right? For the first recursive call, for the first recursive call, I'm considering the first number. So next one, consider next number, right? Okay. Next, I think that is it for what we need to keep track. Let's try to solve it. Let's try to code it out. So okay, let's say the current number is number at current index, right? So we have two choices. Choice 1 is to add current num to sum 1. Choice 2, add current num to sum 2, right? So the recursive call that we are here is kind of like we're asking the questions, right? So if we go this way, if I add the column to the sum, what would be the best, the minimum difference if I go that way? So let's say diff 1 would be 5 million certain sum with the numbers is the same because it's a input, right? But the current index, we want to check the next, want to consider the next number, right? At this point, we don't know what is the difference. The difference between two subsets. If we go this way, if we add column to sum 1, we only know the result after we make recursive calls until it reaches our base case, right? And it get back, right? only in the case we know this difference one. Okay, so because I add the column to someone, so I will add someone here with column which is numbers at current index, and sum 2 is the same, right? Because here I decide to put the current number to the first subset, right? So for this choice that I made, the best difference I can have is diff1. But if I go this way, what is the best difference that I can have? The best difference I can have for this way will be answered by the recursive call with the arguments is numbers. Same here. Index will be the next current index plus 1. Column will go to sum 2, right? So I will cut this out, add to sum 2, and we've got diff2. Now we need to compare the diff1 and diff2. Whatever that is smaller will be our answer, right? So I will return mat.mean diff1 and diff2. Okay. One thing is missing here, which is our base case. We don't want our recursive functions get into an infinite state, right? So the base case here, what would be the base case? It is when the current index is out of range, right? So it means we've iterated, we've considered every number from our input. So if the current index is equal to numbers.length, okay, it's out of range. So now what we want to do here is I will return right. Okay, I think that is just 15.4. It is not a number. What is wrong here? What is wrong here? Come on. No. Probably here we need to return the difference instead, right? We must return the difference for the previous calls. So it should be mat.absolute. Want the absolute value, sum 1 minus sum 2. Okay, it works. there's still something that we want to do here is to optimize it, right? Because if we go this approach, it's gonna gonna not very efficient in terms of time complexity. It go exponential here. So one thing that we can do to optimize our problem is to do caching, because as you can see here, there's a lot of repetitions. There's a lot of repetitions here, right? So for example here, as you can see, this one we have 6 versus 0, 3 versus 3, 4 versus 3, 4 versus 2, right? 1 versus 5, 5 versus 1, 2 versus 4, 3 versus 3, 0 versus 6. Right, as you can see here, we have a lot of repetitions here. So for example here, this one will be called first amongst all of these calls, right? Because we go that first, right? So because this one is called first, so we've got this answer for this one first. But later, so if I got the answer for this call, it means I know the answer. I know the difference, the minimum difference. If the minimum difference if one sum is 6 and one is 0, right? But this way, for this recursive call, we again asking the same questions here. Here is simply a question that what is the minimum difference that we can get with this kind of input. So here we have duplications as well. 1 5, 5 1, 4 2, and 2 4. This is something that we can optimize on. So the idea here is a simple list that gonna catch based on the current index and the sum. So if we have calculated, if we know the result, if we have calculated a given input, right? After we after knowing the answer for that given input, we wanna save it into the cache. So for the next recursive call, not gonna jump right into calculations, but gonna check in the cache. Wanna check if with given arguments, with this kind of questions, do I have the answer for that? Right? If yes, just take from the cache and return it, right? So idea here is simple. So how to catch here? You can do something like catch, right? But that would not be something very good in terms of programming, I think. So let's try to wrap this one inside other functions, right? So the name is same, but I will mark this one as private. I will move the cache inside here so that anything inside our recursive functions can have access to the cache. So here I will call it, right, passing the numbers in. Here it takes in the number from the outer functions, pass it here. This will call this one. Okay, it should still work now, but we don't have any cache yet. Whoops, what's wrong? Oh, we need to return. So I think here I don't want to return the result. I want to save it into result and return result, and before return I will save it into the cache, right? So the thing that I want here is I want to, let's say, const args is I want the key to be an array. And what would differentiate between keys is the current index and the here I don't want to have something like sum1 or sum2 because for example, if sum1 is 2 and 4, if sum1 is 2 and sum2 is 4, so if the sum1 is 4 and sum2 is 3, I'm going to have a different key, right? But actually it is the same questions. So one thing I can do here is I'm going to take the minimum, right, of sum1 and sum2, right? Okay, so before saving to the cache, I will resolve args equal to, sorry, not resolve cache. the cache object a key, that is this piece of data will be resolved, right? So I will move this one above because I'm gonna need it. So if it comes here, I will check it in the cache first before doing anything here. So if we have it in the cache, right? These arguments we have in the cache. This means we'll return right away. Okay, let's run it again. Okay, that's it. So it works. So thanks for watching. It's been a long video already, so appreciate if you go sit along with me, this far with me, right? So thanks for watching. See you in the next one.